The celebrated Achievers Mentorship Program, CHAMP, bringing academic dreams to reality. So in this video, we'll be talking on the electrochemical cell. Electrochemical cell. So yes, let's move. Now, what's electrochemical cell? Now, I told you in the previous video that we have two types of cell. We have electrolytic cell and we have what electrochemical cell. Now, let me just give some recap. You can just check out for the differences between electrolytic cell and electrochemical cell in our previous video. Yeah, but you know that in this one, anode is positive, cathode is negative. Here, cathode is positive, anode is negative. I gave 7 differences in the last video. You can just check it out because of time. Yes, let's move on now. The examples of electrolytic cell, we have Dance cell. Dance cell is used in the extraction of sodium. We have diaphragm cell. Diaphragm cell is used in the extraction of in the production of sodium hydroxide. We have hookah cell. Hookah cell is used in the production of sodium chloride. We have oil process or oil cell used in the extraction in aluminium. Let me give the uses of electrochemical cell. Electrochemical cell, we have some examples. Let me just give them. We have Danius cell. We have Leclanche cell. We have lead acid accumulator. These things are very important. They ask a lot. Then we have alkaline accumulator. Then we have what? We have electric eel. Electric eel. So yes, let me just talk on them. We have this will be the space for the cathode. This will be the space for the anode. Then in case the electrolytes, the electrolyte. So let's go. Take them one after the other. Danius cell, Leclanche cell, lead acid accumulator, alkaline accumulator, electric eel. Yes, let's take that together now. Yes, let's go now. We have Danius cell. Yes, what's the cathode of Danius cell? Is what? Copper. Don't worry, I'll give you a mnemonic on this now. The cathode of Leclanche cell is also what? Copper. So CCC is copper. What's the okay, no, this one is carbon, sorry, but it's also C, carbon. The anode is what? Zinc. A to Z. The anode of this one is also what? Zinc. So this one is copper zinc, this one is carbon zinc. Copper zinc, carbon zinc, copper zinc, carbon zinc. What's the electrolyte of Danius cell? Dilute H2SO4. Dilute H2SO4. Now Leclanche cell can be in two forms. We have the dry form and we have the wet form. Yes, for the dry form, we have what? Ammonium chloride paste. It will be in form of Maclean paste, don't mind me. Then this one will be what? Ammonium chloride solution. Ammonium chloride solution. Please mark the difference between dry and wet form of Leclanche cell. Yes, let's move on. Now for this, let me give you a mnemonic. Danius, cousin, length, camphor, Zinger. So this is what? Danius cell, cousin, copper zinc, length, Leclanche cell, camphor, carbon, Zinger, zinc. Danius, cousin, length, camphor, Zinger. Yes, lead acid accumulator. You have what? Your cathode is what? You can just use the mnemonic alloclear. Alloclear. Yes. What's your acid? Your anode is what? Lead oxide. Anode is what? Lead oxide. Cathode is what? Lead. Cathode is lead. Yes. So let's go now. Anode is what? Lead oxide. Lead oxide. Then cathode is what? Cathode is lead. So take note of that. Alloclear. Alloclear. The electrolyte is what? They said lead acid accumulator. So you know that should be what? H2SO4. H2SO4. So lead oxide as the anode, cathode is lead. Then the electrolyte is what? H2SO4. Alkaline accumulator, just use names mnemonic. Nife. Yes, this one is what? Nickel, and this one is what? Iron. Don't forget your cathode is positive, your anode is negative. Then electric eel, use this mnemonic. Chat. Okay, what's the electrolyte of alkaline accumulator? Now you hear something alkaline, so your electrolyte must be an alkaline. KOH. Do you get it now? Yes, electric eel, chat. cathode head, anode tail. Cathode head, anode tail. So cathode is the head of that fish. Electric eel is the fish that conducts electricity. The fish that conducts electricity. Cathode head, anode tail. Chart. Then the electrolyte is what? The body of the fish. So never forget this. If you don't get it very well, just play back and listen again to get it fully. Electro potential. Now, yes, what's electro potential? Electro potential is the ability of electrodes to do what? To gain or lose electron. To gain or lose electron. So we can have reduction potential, and we can have what? We can have oxidation potential. Now what's reduction potential? The ability of an electron to the tendency of a electrode to do what? To gain electron. I hope you know I get this definition from. Reduction is what? Gaining of electron. Oxidation, tendency of an electrode to do what? To lose electron. Are you following? Now there's something we call standard reduction potential. Standard reduction potential or standard oxidation potential. Standard oxidation potential is when the oxidation potential is measured under standard condition. Standard reduction potential is when the potential is measured under what? Standard condition. And what is the standard condition? The standard condition is that the temperature must be 298 Kelvin or 25 degrees Celsius. Then the pressure must be 1 atm, and the it must be referenced against hydrogen. The oxidation potential or the reduction potential of hydrogen is 0.0. So let's go now. Let's check reduction potential. The tendency to do what? To gain electrons. So let's say we have something like this. Cu2 plus what? 2 electrons. We give you what? Cu. This is a what? This is a reduction potential. You must be able to identify reduction from what? From oxidation. So let's say the reduction potential of this one is what? Is 0.34. We have that of many elements. That of K plus to give us K plus electron to give us K is around minus 2.93. That of calcium, they will not ask. They will never ask you. I just want to explain something. Now, the more electronegative, the reduction potential, the more the reducing ability. So the more electronegative the reduction potential, the more the more the reducing ability. So if they give you the reduction of potential of something to be minus 2.8, and another one, A minus 2.8, B minus 1.5, C minus 0.3, then D plus 0. They said which one will be the strongest reducing agent? What will be your answer? Minus 2.8. Do you get it now? Minus 2.8. Do you get it now? Yes. Let me teach you. So yes, this is what I told you there. The more negative the reduction potential, the more the reducing ability. So the more negative, the more the reducing ability. So take note of that. Now let's move on now. So we have some other things. Let's say we have I'm coming. Yeah, let me quickly talk on oxidation potential. Then how to change oxidation potential to reduction potential and all of that. What is oxidation? Loss of electron. So it will just be something like this. Maybe you have Zn minus 2 electron to give you what? Zn 2 plus. This is what? Reduction potential. But it will not be written this way, minus. You just see that your minus is what? Is in the other side. Zn to give you what? Zn 2 plus 2 electrons. This is what? This is oxidation potential. So this can be what? Plus 0.76. Another one, maybe we have Mg to give us Mg2 plus 2 electron. How do you know there is loss of electron? This plus, it should be here. So it is what? There is loss of electron. So yes, there is what? There is loss of electron because it should be here normally, minus 2 electrons. So now let me teach how to change oxidation potential to reduction potential. Let's say we have the oxidation potential of, okay, let me ask you, Zn2 plus 2 electrons to give us what? Zn. Well, is this okay? Yeah, let's say this is minus 0.76 volts. Yes, is this reduction potential or oxidation potential? Yes, so let's move on now. So it is what? It is reduction potential. What is the reason? Because it gained electron. So if you want to convert it to what? Oxidation potential. If you want to convert it to oxidation potential, just reverse it. Zn will give you what? Zn2 plus. Will give you Zn2 plus what? Plus 2 electron. This is what? Oxidation potential. So I just reverse it. And what will happen to your sign? It will change. It will become what? Plus 0.76 volts. Do you get it now? You get it now. So let me give you another one. Let's say you have Cu2 plus, or let's say Cu to give you what? Cu2 plus 2 electrons. Then, okay, yes, let me ask you, coming this minus 0. Yes, let's say minus 0.34. Yes. Let's say, yes, is this reduction potential or oxidation potential? That's what? Oxidation potential. Because loss of electrons should be here. So, yes, let's change it to reduction potential now. So, it will be what? Cu2 plus 2 electrons to give you what? Cu. Your sign will change. Plus 0.34 volts. So, it's as simple as that. Now, let me just write what you the representation of electrochemical cell. Representation of electrochemical cell. How do we have a represent? Yes. Now we have representation. This is an electrochemical cell. This is a salt bridge. This is an anode. This yes, anode, cathode. Right? We have an electrode. We have an electrolyte. I mean. Yeah. Let's go now. How do we represent it? We have the first thing you write is your what? Your anode. Anode. Then you put what? A slash. And then your what? Your electrolyte. Anode electrolyte. Then you put your salt bridge. What is the sign for your salt bridge? Double slash. Then you have your what? Cathode electrolyte. Then after that you have your what? Your cathode. Please never forget this formula. Anode electrolyte, cathode, anode. The electrolyte are always in the what? Middle. This is it. Electrolyte in the middle. This is your anode there. This is your cathode there. The one that lasts. Then your salt bridge is in the middle. Anode electrolyte, salt bridge, cathode electrolyte. They can ask. This is a jam question. This double sign represents what? Salt bridge. It's as simple as that. This single line represents what? The interface between your anode and your anode electrolyte. So let's move on now. So we have. Let's go to the calculation of standard cell potential now. The calculation of standard cell potential. Now, the first thing you should identify is your anode. What will be your anode? Then what will be your cathode and everything. Now, for a cell to be spontaneous, your anode must be a metal that is what? That is higher in the electrochemical series. Anode must be what? Higher in the electrochemical series. Why? Because you know that anode is used to what? Coat the cathode. So what must be used to coat your cathode must be stronger than that cathode. So your anode must be stronger. So your anode must be higher in the electrochemical series. That's just that. Yes. Let's move on now. Let's take some question. Let's say we have something like this. Then they ask you to do what? They ask you to write the. Let's just take a practical question. I don't have a lot of questions here. So I don't have many questions at my disposal here, so we'll be using this. So yes, we have question 55. They said if the overall reaction in a cell is what? Mg plus Cu2 plus to give us Mg2 plus Cu, the symbolic representation will be what? What will be the symbolic representation? So I said, so what's the formula? Anode electrolyte, then cathode electrolyte, then cathode. Yes. How do you know your anode? The one that is what? Higher. Which one is higher? Magnesium. So you have what? Magnesium electrolyte will be what? Mg2 plus. Then cathode is what? Cu2 plus. Then Cu. So this is your formula. What's your answer? Then you must be what's the unit of magnesium? That's what? Solid. This one is aqueous. Your electrolyte is always aqueous and what? Solid. So yes, what's that? That's option A. Magnesium, Mg2 plus Cu2 plus and what? Cu. So that's just that. Do you understand it now? Oh yes, so that's just it. Yeah. So let's move on now. Now the calculation of standard EMF is just as simple as ever. This is just it. So you have a reaction like this. They now said, what's the standard EMF? Some people, don't let me say they will just add these two together. It's very wrong. It's very wrong. Don't just add the two together. Anything that you have, you are just adding. So yes, it's very, very wrong. It's very, very wrong. So yes, how do you do it? How do you do it? Now, this is just the principle. Between copper and iron, which one is higher? That's what iron. So you have what? Fe. Iron should be your what? Iron should be your anode. So you have Fe, right? Fe2 plus. Are you following? Then Cu2 plus Cu. Do you get it now? Fe2 plus Cu. So this reaction is, if I want to write this reaction in full, this is your what? Anode. And this is your what? Cathode. If I want to write this reaction in full, it's the same thing as what? Fe to give me what? Fe2 plus what? 2 electrons. Do you get it now? Anode, oxidation, loss of electron. This is loss of electron. So in this place, they give you Fe2 plus 2 electron, which is what? Minus 0.44. Check something. This one is what? Fe2 plus 2 electron minus 0.44. Now we've reversed it. What will happen to your E naught? It will also be reversed. So it will be what? Plus 0.44. Can you see now? Now, what do we need? Here we need what? Cu2 plus to give us what? Plus 2 electrons to give us copper. That's your cathode. Cathode is what? Gain of electron, reduction. So it's there already. Cu2 plus 2 electron. So that's what you have. E naught is what? 0.34. So it's after you've done this that you can now add. Not at the beginning. So you have what? Plus 0.78 volts. That's the answer. Now let's check this question. Now I told you something, that this is what? Reduction potential, everything plus electron. And I told you that the more negative the potential, the more the reducing ability. So they ask you, which of the 4 metals above is the most powerful reducing agent? Come back, what's the answer? Just think very well. So yes, which one is the most negative? That's what? That of potassium. So potassium is the most powerful reducing agent. Okay, yes, I'm happy we have another type of this question. We have what? Magnesium. If you can see, this one is a what? This one is an oxidation potential, right? This one is also an oxidation potential. So they are both oxidation. Now, which one should serve as? Yes, this oxidation potential. This is also oxidation potential. But you know that one should be your what? Reduction potential. So one should be reduction potential. One should be oxidation. One should be reduction. This oxidation is your what? Anode. This reduction is your what? Cathode. Now, which one should be your anode? Is it the metal higher or the metal lower? So yes, it's the metal higher. So which one is the higher? Magnesium. So this one is your what? This one is your oxidation potential. Cathode is the what? Is the one lower. So reduction, silver is the one lower. So this will be your what? Reduction. This is your oxidation. So this oxidation potential already is correct. So this one is your what? Reduction potential. So you have to do what? You have to reverse it. So the sign of this one will change. 0. Plus 0.0. This one is what? Plus 2.37. So add it up. That will give you what? 3.17 volts plus 3.17. Do you get it now? So yes, that's just all about calculation. If you've not gotten it, please just play back, watch it again, watch it and watch it over again. You will definitely get it. Yes, let's move to the last one now. Yes, now for this last one, we have what? Let me just talk on rusting. Now, rusting is a special case that involves is a redox reaction. Note that is a redox reaction. Yes. How can we prevent? Now, rusting is referred to as what? Corrosion of iron. Actually, iron is the second most abundant metal in the air. Is the second most abundant metal. The most abundant metal is what? Aluminium. So we should actually be using aluminium because aluminium does not corrode and it's very abundant. It does not corrode. It will not rust. It doesn't corrode. So aluminium does not corrode. So we should normally use aluminium, but we don't use aluminium. Aluminium is not in wide use because the extraction of aluminium is what? Is expensive. So we use what? Iron. But iron gives us problem because iron corrodes. So we spend millions of naira every year all over the world. in fact trillions to prevent the corrosion of ions, because you use iron almost everywhere. You use it in roofing, you use it in making window panels, you use it in production of cooking utensils, you use it in many things. So we spend a lot of money every year to prevent the corrosion of iron. Now the corrosion of iron is termed what? Rusting, and it requires two things. Moisture and what? And oxygen. Moisture and oxygen. Romans chapter 10 verse 13. Yes, R is what? Rusting, O is oxygen, M is moisture. Yes, so please take note of that. So yes, that's just about rusting. That's all about rusting. So we have what else? Yes, so how do we prevent rusting? Quick, we can use what? Electroplating. Plate it with a metal that is stronger than it. We can use what? Galvanizing. Paint it with what? With zinc. We can use what? Painting. We have painting. Then we can have some other thing. We can have greasing. We can have oiling and many other things like that. So let's just tackle the question we have here. Yes, the most suitable method for preventing the rusting of petroleum pipelines. Petroleum pipelines is what? Yes, protect with its magnesium. Something that is what? Stronger than iron. Something that is stronger than iron. That's what? Magnesium. You can't use tin. Oh yes, so we can't use tin because tin is what? Tin is than magnesium. You please call mass in this iron, then tin is under. So I said you should use something that is greater. Why is iron galvanized with zinc? Because it is what? It is greater. It has a more negative reduction potential, or a less. I said the lesser the more the negativity value, the more the what? The reduction potential. So that's why it has a more negative reduction potential. That of zinc is what? Minus. It's greater. Zinc is, I can't remember the precise value now, but let's say this one is minus 2.93, but you know that iron will be what? Less than this one. So zinc can protect iron because it has a more negative reduction potential. Yes, which element is used in electrode in car batteries? I treated this already. Alkaline and lead acid accumulator. So we use what? Lead. Yes, which of the following can be used as sacrificial cathode for preventing corrosion of iron pipe? What is what? What is greater than iron? Yes, so that will be what? Magnesium. Which of the following is exemplified by rusting? That's what? Redox reaction. Let me just give you some bonus tips on rusting. Now, because when you are treating your past question, now we do quote the underparts of sheep. Yes, we make it with iron, so they can rust. And if the underparts of sheep rust, water will be entering the sheep. So the sheep will no longer be safe. So to prevent the rusting of the underparts of sheep, we can't use painting. We can't use oiling because it will be in contact with water. So it will not last. We can't use greasing. What are you greasing? You can't use painting. It will be washed away by water. What will be under water for many years. So what we use is what? Coal tar. We use tar to prevent the corrosion. The same thing for spoon. Or your cooking utensils generally. If you say you want to prevent if you notice your cooking utensils, they don't rust. What's the reason? Yes, I will tell you the reason now. They've been coated with something. If it is ordinary iron, they would have been rusting. And you can't prevent them by painting. The painting will be reacting with the food. Do you understand? You can't react them with oiling. The oil will react with the food. It will not last. How will you even with grease? So you are eating Vaseline with your rice. So it doesn't make sense. So what you use is what? Enamel. And why do we use enamel? Because it is HID. This is a jam question. Because it is hard, it is impervious to water. Water does not affect it. Water can affect every other thing, and it does not react. With what? Does not react with the food. It doesn't react with food. This is the reason, HID. So this is the bonus tip I have for you. With this video, you should be able to solve every form of question on the electrochemical cell, on the electrolytic cell. If you are sure to check through all the videos we've made on this topic. Thanks so much for staying through to the end. This is the Celebrated Achievers Mentorship Program, Champ. We are bringing academic dreams to reality.